downside to a fantastic introduction is that all of the good things were already said.
That's Los Angeles. You can always recognize it by trees. And that's me, Rainer Banham, crossing the road. I'm Professor of the History of Architecture at University College London. And you might wonder what I'm doing in Los Angeles, which makes nonsense of history and breaks all the rules. Well, I love the place with a passion that goes beyond sense or reason. I come here as often as I can, but this time there's an added attraction.
Welcome to Los Angeles, the super city of the future, the metropolis of Southern California. For the benefit of discriminating visitors, this car has been equipped with the Beta Car Visitor Guidance System, courtesy of Pennywise Car Rentals and Sunset Gasoline. The clean gasoline.
Helps fight smog.
So we wanted to begin by thanking everyone for being here this evening, and we also want to thank the Architectural League for hosting this series and to bring us here to New York. And lastly, not only that is that we're 4 GSD grad, Jinhee, Dwayne, and I were actually all in the same class as well, so it's kind of special to all be here together. We wanted to show the Rainer Banham video. In some ways, it was the same experience we had when we first moved from New York to LA. We really felt like a foreigner in a strange land. We really didn't know what to expect and how to operate in such a different city. And now, 8 years later, we've been in LA about the same amount of time as we've been in New York now. While I think that New York will always have a special place in our heart, I think that our office, the trajectory of our office has been really shaped by our experiences in LA. So today we're actually going to talk about a few topics, things that we've been kind of obsessed with in the past about 6 years since we started the office. And we will talk about 2 to 3 projects in full, but we will also show a lot of the other projects as we talk about the topics. So being that we knew no one in the architectural community when we first got to LA, one of the things that really shaped our experience in LA was the fact that we started teaching at SCI-Arc. Dwayne has been there for 8 years, and I have been there for 6 years. And the building you see below is the quarter-mile-long building that SCI-Arc is located. And the projects above are actually my first-year students. I lead a design-build studio for the last 6 years doing design and build, and then they've left remnants of the projects throughout the school. So one of the things that about LA we found that was amazing was obviously the weather, and that has helped us really have the opportunity and also space to have the opportunity to actually design and construct our own work. And when you move to a new city with no clients or any prospects of clients, you realize that you have to make it up yourself. So I'm going to quickly kind of browse through the first 2 projects. Of course, the first one being our own studio. We moved into a loft. It's called the American Cement Building. And we decided that since we need an office, we need to make it into a live-work space. We only want to spend about 1 month of rent, which was about $2,500. and we built it out of mainly just plywood and 2x4s.
The $2,500 doesn't include the $50,000 worth of our own labor that went into the making of the piece.
And then, of course, the second project is, you always do something for your parents. So the second project is a outdoor deck we did for my parents. In this project was the first time we had a couple of SCI-Arc interns over the summer, and we actually built the thing over the course of the summer and completed. Which led to this idea that, wow, we can actually make projects happen in a period of 4 months. So ever since this was about 5 years ago, every single summer we've embarked on a installation project, sometimes even 2 in the beginning or the end of the summer. And we've had mostly SCI-Arc interns help us in the construction of them.
So we thought it was important just to show those first couple of projects, to show you how we began in LA. Immediately after this, the work took a pretty dramatic turn, but to understand how the work's played out over that period of time seemed important to us. As Paul mentioned, the idea of line work is something that is something we've been really intensely studying for many years now, and we even went back and pulled out a couple of our own projects for the lecture. A work of mine from about 94 on the right, Jenny's thesis from the GSD on the left. And Jenny had always been interested in ideas of line related to infrastructure and program. And so her thesis had to do with an idea of wrapping program around these infrastructural pieces and the kind of spatial and organizational implications of that. My project on the right was about the interplay of light on these complex structural elements and sort of immersing yourself in that into that space. The type of line that we're interested in has never been a graphic idea. If you look back at both of those, what in these seem like relatively two-dimensional pieces, when you get down into them, it was really about creating spaces that could be experienced and, as I said, that you could be immersed into. We've always been interested in very dense buildup of lines, and in particular the idea that this kind of buildup had the ability to create nuanced spatial enclosure, so that while experiencing it, your experience oscillates between something that forms enclosure, it's immediately in front of you, and something that in an instant flowed back into spaces or multiple spaces.
This is a project we did for the Guggenheim. It was for the show Contemplating the Void. And they had actually asked us to do a two-dimensional drawing. And so we decided to give them a 2-inch two-dimensional model.
The types of drawings that we've done over the years have also dealt with this idea of lines and a couple of different types of studies. On the right, sketches that have been done over long periods of time related to no particular project, but that are really meant as a way of expanding spatial comprehension in the drawing. We've found that the more these have been produced, the more we could sort of predict how to draw them better. So the earlier ones were relatively simple, and now most of the ones on the right are my drawings. I'm able to further anticipate what will happen in the drawing compared to the way they were drawn in previous years. The drawings on the left are both meant to capture the technical aspects of the projects, but also to convey a sense of the spirit, in this case, a project that moved that we'll go into a tiny bit later. We've always been interested in the idea of structure of line work as a structural element, in particular because we have always believed that part of the experience of the line work, part of what enriched that experience is the idea that you could somehow prolong the experience by creating work that you encounter without completely understanding it. It's never understood as an instant gesture, but it takes time to understand. on one hand, you know that it's doing something structurally, but it's a relatively inefficient system. The goal has never been to do it from an engineering standpoint, but to create something that's clearly working, but forces you to engage it in order to understand how it works. So in order to do that, you have to trace lines across space, understand their connectivity, and we believe that's enriched the experience. The one other thing I wanted to say about the line work is that the type of line work we've always done has always gotten at a sense of movement, partially because many of them either have moved or dealt with programmatic movement, such as the stair, as well as the Ali one was also sort of about capturing that idea of dynamic movement.
So we want to talk a little bit about our process, and mainly because we feel like in some ways our process is a little more messy. We don't hold allegiance to one technique or one method, but we really think that you have to use it all in order to produce something great. So, one, we build tons and tons of models. We kind of average in the 20s for each of the models for each project. And this is a structural model we did for the Muhammad Ali project, which we will talk about later. And then we also work digitally. I think that while the physical model was great for understanding gravity and understanding even structurally how it would work and operate, I think the digital model allows us the kind of computational power to create the type of variations that's not we can't do in the physical model, and also it gives us the precisions that we couldn't do either. And so with this, we were able to really create variations on something that could be just, in a very slight parameters. And then we still believe in although these are not the fastest way to sketch, but it is fast for Dwayne. We do believe in sketching, and also just how to put an idea down quickly on paper is the best way to show an idea. And the step further that we do is that we really believe in actually building the work and understanding and prototyping, and understanding that the design doesn't stop at construction documents, but it actually pushes into the whole fabrication process. So we would oftentimes literally design a detail and then implement it the next day. So these, as you can see, are kind of all the students from SCI-Arc that have worked with us, and some of the students and some volunteers as well.
And we went into the projects we never went to LA thinking we would build anything. We didn't have any, although we're handy, we didn't have any particular skills in building. We had never welded or anything like that. And we just found that it allowed us to extend the process much further than we had been before. Like she said, there are often times where the thing is 99% built, and we go back, we build a model on the last day to finish a piece that we're kind of rethinking.
Yeah, it's just to say that we really, other than the wood construction that we did in the first two projects, everything that we've done since then is a learning through the making, and we've never welded, we never even used metal, we didn't know how to do it, so.
Beginning in about 2005, we started a series of projects, and we're going to talk at length about two of them, but we wanted to show briefly all four of them. And in many ways, they're addressing similar problems. And we wanted to say something about why we kept doing this. We got out of school with the almost sense of moral obligation that with each new project should come a brand new idea. And the more we did those projects, the more we found that we weren't making any real progress. That we would just scratch the surface of an idea. We were left with many more things we wanted to study. And with each one we did, we felt like that sense of moral obligation changed from we shouldn't do it again to we absolutely had to do it again, so that the work could grow not just from a material expertise, not like a contractor would develop expertise, but we learned what the work could do in terms of its experiential effects. We would learn technical aspects that would influence the the actual outcome of the work from a design standpoint, not from a technical standpoint. The first of the projects that we did was one called Density Fields of Materials and Applications, an outdoor gallery in Silver Lake in Los Angeles.
And this was a kind of a structural experiment. We created this 23-foot cantilever.
And the second was a competition that we won for the LA Forum for Architecture and Urban Design. It was a shared space. The competition called for a piece that was meant to be, because it's shared, it was meant to be put in a closet the majority of the time. And our response was simply to say that it didn't make sense to create something of any real architectural value and put it in the closet most of the time. So we designed a piece that functionally operated as a exhibition hanger, series of exhibition hangers, but that piece could be tucked up into the ceiling and serve just as a ceiling plane. So on the right, what you're getting is the modular reading of the individual pieces, where on the left, it just becomes this field of complex aluminum tubing. The third of those was a project in the SCI-Arc gallery called Live Wire that we'll go into a little bit more. And the final was one called Realize, a tribute piece to Muhammad Ali that we'll also go into. So that third project was called Live Wire. And most of you probably know, but SCI-Arc hosts gallery installations 3 or 4 times a year. And at the time that we did it, there had been about 30 installations in the gallery. Shocking to us that there had been that many. And many of them were absolutely fantastic. But one thing about the space that really struck us as interesting that no one had addressed yet was if you know the space, there is a catwalk that can be seen up to the right, and there's a series of clear-story windows to the left. And very early on, we decided that we wanted to make a stair that would allow you to move from the gallery up to the catwalk above you. And we started looking at the problem, continuing this idea of line. And something that we knew had to be added to this project was the idea of surface, because it obviously had to function as a stair. It was a complex problem of trying to weave in both the line work as well as planar elements. When we did density fields, this was the technique that we used.
Which is the first project.
Yeah, the first one, the big cantilevered piece. For every joint, we were taking aluminum, we were chopping it at the joint, we were grinding them down, re-welding them, grinding them again, and then sanding them. There were roughly 100 joints. It was kind of crazy. In the second project, and so what you're seeing there is an adjustable jig that would allow us to make all of the joints. On the right is an unrolled rhino file that we could cut out on paper. We would wrap it around the tube, trace the cut, and then cut it with an angle grinder. Well, the next proposal for the pendulum plane, the ceiling piece, was so incredibly complex that we realized that the only way we were going to accomplish this was to come up with a different technique. And so we went to bending. Very inexpensive radial draw bender would allow us to bend 1-inch and 2-inch tubings for the dies that we had. And aside from the technical aspects of this, what it did, well, it allowed us to make much more complex pieces, but it also really changed the reading of the work. Suddenly, the idea that we could make a complex field that read as a field as opposed to a series of trajectories was a totally different reading, and it completely changed all of the work that followed that. Because it was done for the SCI-Arc gallery, we had a lot of students who would come in and they'd say, I've got an hour, what do I do? And we needed to come up with systems that we needed to think about this thing strategically and organizationally so that a student could walk up and you could direct them to be able to work on the piece. So the piece was broken down into a series of loops. And the loops was the idea of the loops was both a conceptual problem and an organizational problem. On one hand, it was about identifying, you go work on this loop. On the other hand, the idea of the loop had to do with with the overarching concept of the project, which had to do with trying to weave together something that could address issues of light up at the clear story that could then transform across the space into something that was the size of 2 treads. And within that single continuous loop, you could create wing-like, light-filled element, guardrail, handrail, tread, riser, up again, and then starts the entire process all over again. So, if someone comes to work on it, you go to that image at first, you direct them, and then they'd come to this sheet where they could find stick of aluminum, here's where you bend it, this is what the bend needs to be, here are the lengths, etc. All of the projects involved the making of really elaborate wood jigs that were first built in a digital program and then were constructed on the site. The reason for the jigs was simply to ensure that the piece came out right. The way these three-dimensional loops worked were we would love to have a CNC bender that just made all of those for us. We didn't have that. We would make them one bend at a time. So for any loop, you might have 20 bends along that, somewhere in that tube. But for each one, what would happen is we'd make one piece that was straight line bent. And then you'd take the next piece and you'd connect it, and you'd have to rotate that piece using a telescoping connector until you got the right geometry. You'd then place that in the jig, and it would ensure that the overall geometry would be right. We only had about a week and a half in the actual gallery, so the piece was first constructed in the parking lot. The entire jig pieces were welded together when they could be, still allowing them to get through the door. We then took the entire jig apart. We took it into the gallery. We reassembled the whole thing. We started welding all of the units together, and then the jig was slowly cut out one stick at a time, allowing us to test the structural integrity of the piece as we went.
And then this is this piece where we actually start to put the infill perforated aluminum panels.
Here you get a sense of the loop that I was talking about. On the top, really elaborate piece, and there are, 20, 25 different sticks of aluminum in that were assembled together. In the middle, you see what was really the hardest design problem of all, and that was that the panels needed to be captured within a piece of aluminum tubing. So that idea that the tube had to go up and come back down and eventually completely wrap the piece, like I said, was both a conceptual problem and a technical problem. Hence the 20, 25 models that were working on that same issue.
So, and then to talk about this structurally was kind of an amazing challenge. When we proposed to our really excellent engineers at Bureau Happold that we wanted to build a functioning stair out of 1-inch aluminum tubing, they thought we were crazy. And we didn't, and they thought it should be at least something to the 2 to 4 inch range. And so we convinced them that instead of using larger members, how can we layer more 1-inch aluminum tubes to make the strength of the larger members? And so what was then developed as a system of creating these ties that break up the larger spans, as well as reinforcing and the stiffness of the tube. At the same time, I think engineers really, this is definitely not something that they're comfortable with. The stair is really soft, so when you walk on it, it's super bouncy, which was thoroughly tested at the opening. So, but also for the 2 months period, we would get these comments where students said, "Oh, I took the stair today." They would bypass the normal stair and took our stair to get down. And so here you can see the aluminum panels.
And I've probably beat this like a dead horse, but in the upper left, there you see how those pieces, if it wasn't clear, how those pieces were assembled. They were all laid flat on the ground as single bent pieces, and then it rotated into place. I don't have a pointer. Then rotated into the place as you move down. Can that point on that?
Yeah.
Yeah. So there they are laying flat on the ground, each getting rotated until you get that shape, then you come across, and in certain cases you get, you get the tube element being combined with the planar element. Those were eventually put in the jig. And this diagram is just showing you one component of, and there were 6 or 7 of them.
So this was the opening we were talking about. And, you know, it was kind of a fun thing because we had people up above on the catwalk and everybody was taking their kind of ceremonial walk up the stair. So, realize, and this is our, what we call the provisional end to the aluminum tubing project, at least at this scale. So, this was done last year. It was at LA Live, which is a space right across the street from Staples Center where the Lakers play. So definitely a very different kind of venue than we're used to. We were approached by an artist named Michael Kalish, who does a lot of portraits for celebrities and icons. And he had an idea about doing a tribute piece for Muhammad Ali. And mainly it was an idea about how do you create the face of Muhammad Ali through the use of punching bags. And what he didn't understand was how technically, in terms of the ideas of perspective of how to pull that off. And also he didn't realize, you know, how much punching bags would weigh and how do you actually structurally, you know, hold all of these things together. So this was one of the actually one of the only physical model we built with the bags, even because it was completely very difficult. We used fishing weights to test because for the longest time we actually didn't even know if this idea was going to work. It worked in our Maya model, but we knew that in digital space it flattens out and it looks perfect, so we weren't sure. And on the left is an image that we took of this model, and even though it's sort of blurry, we got the point that this is possible. So a little bit about, this is the overall structure, and the structure was also, this is one of the biggest, at that point, the biggest structure we had done. It was over 2 stories tall, and it had to be done as a modular system, which really is a very difficult thing. If you want the piece to feel like they're kind of all the pieces to feel integral to each other. So there was a very complex way of actually nesting one module with the other module. And this was, now we built a really giant jig for our structure. And it consists of mainly 2-inch aluminum tubing as well as 1-inch ties.
In many ways, one of the big aspects of this one is we'd never been asked to create something that was modular before. And if you look at the work, it doesn't want to be made modular. In order to get that dynamic sense of movement, you've really got to get tubes nested within one another. And so there was a very elaborate system of trying to nest it inside of itself with each of the legs, but still allow it to go back together in a very quick, through a very quick process.
So this is more fabrication drawings. We use Grasshopper to organize all of our, lengths. We had over 1,300 punching bags and at various heights and 3 different types, small, medium, large, and 2 different colors. So, as you can see a little bit here, is that the punching bags are suspended. They're suspended, but they're actually stretched on both ends from the frame above and below.
With this project, the big question for us is what is our role as architects? There was an artist already along. He had a pretty clear idea to begin with about what the face could be. And what we always said in the office was that what we needed to do was create a piece that people would go to and they would absolutely appreciate it as a piece of art or architecture before they ever knew that they were there to see a face. And so it was very much about people walking around the piece, being intrigued by the dynamic sense of movement that was created through the piece, seeing that complex field of bags and the kind of sparkle of the stainless steel cables. And then eventually arriving at the face and understanding that that was sort of what brought it all together. Here you see the face just starting to come into view. And finally, Muhammad Ali.
So one thing I want to also add just before we move on is that this was also the first project that we actually had someone outside of the architecture community see it, and that was really exciting. And in some ways, that the project works on many levels. It can appeal to the sports fan who just love Ali, and also even as a young kid, there was something for them to get. Like they can, if nothing else, they can go and take an image at the spot, and wow, there's a face, right? But then there's also the people that actually don't care about the face, and they want to see the structure and want to see the overall piece. And I think that was, really exciting for us to actually kind of, move out of just the purely architectural community. So.
Every year for the last 5 or 6 years, SCI-Arc has asked a faculty member along with the students to build a graduation pavilion for the graduating class. And what we were asked to do was create a, quote, tent that housed 1,000 people and provided shade for 2 hours one day out of the year. And we had a couple of reactions to that. The first was 1,000 people, that's a lot of people. And it forced us to deal with the fact that we weren't going to be able to do the thing we normally did. We weren't going to get elaborate form over that amount of space.
With aluminum.
With aluminum, both for costs and for labor reasons. And so we were forced to think about how to use the natural behavior of a material, an inexpensive one, and probably one that could span easily in tension. And secondly, the idea of creating a tent implied that there was a single plane. And we were much more interested in creating something that was thick, that had space. And so we went into it with the idea we wanted to create this net system, and within the space of a couple of nets, a couple of layers of nets, would become the shading device. So the nets that we started looking at we thought, well, let's go out and buy a net. And we quickly realized that most nets that you purchase are knotted nets, not knitted nets. And what that means is that every intersection is knotted, and the piece isn't malleable. You couldn't take a square and bend it into random shapes three-dimensionally. You'd get things floating around, and you lost control of it. But the knitted net was completely malleable, and so it allowed us to make different sorts of shapes, and the nets would adjust to it.
But we didn't know how to knit, so.
Yeah, so we watched YouTube. We immediately started watching old women knitting things.
And we started knitting.
And we began knitting. And we started making models out of
We
yarn
knitted
and
models.
string in different configurations. And most of the work for this project was done through large physical models because it was the one thing that would tell us how the natural behavior would occur. The scalloping, for example, of the front of the nets as it folded over. And in many cases, we had multiple nets that were tied to one another, so you get strange behaviors acting in many different directions.
So our students wouldn't admit to this, but they were kind of embarrassed to be knitting in studio. But this is in our backyard. We start building this really giant model where they also knitted the nets.
For the structural elements of the piece, we also had to think more efficiently about this one. So rather than the elaborate jigs that were created for the previous projects, all of this was done on a flat surface. And then, so we reduced the project to 3 big trusses and 3 different types of columns, but many of them, all of them were doubled up. So you'd build them flat, you'd then three-dimensionalize them and weld them in the transverse direction. The knitting was actually done using 40-foot-long 2x4 jigs. We did a fair amount of experimentation with the jigs, looking at the spacing that was required in order to create the distance that would ultimately be needed. All of the work was done, as much as possible, was done on the ground. So you've got the roof element of the major component of the piece being laid on the ground, three-dimensionalized as much as possible, and then the net knitted across it. And then eventually, when we get to the end, knit it out into the parking lot.
And then raised.
So that when the piece got raised, the net could
Fold over.
To the underside.
So you can see on the right, that's how the net actually, if each bay is actually one piece of rope that wraps all the way around from the top to the bottom.
And we didn't have an elaborate budget for this. We didn't have a crane. We had a rented forklift for a couple of days, and we had a half-working forklift that SCI-Arc owns. So rather than craning the pieces into space, we had to think about how to tilt them up, back end, and then the front end running between forklifts, inching it up a foot at a time and eventually putting the columns in place. So in this image, and I think the next one, you're just starting to see on the far right there, you can see that half of the net has been attached to the structure, and half of it is still hanging to the ground.
Actually, it's kind of an interesting story because when we did this, when we were at this point, we thought, what if we totally ruin it with the fabric? Because we kind of was falling in love with the whole kind of nets. So, but then we put it in.
And at this point, we're out in the parking lot with the enormous model placed in the right orientation, calculating the shading that we were getting. And we had done a lot of studies in different digital programs, some that accounted for daylight savings and some that didn't. And so we were never 100% sure that we had gotten it right. So the model, we literally were working on that model up to the time that we put the final louver in place.
So this is the final piece.
So here you really get a sense of the natural behavior of the net, even within the field. So the pieces are looking like they're almost blowing in the wind, but they're really just taking on the natural curvature of the net on the upper layer and the bottom layer.
So this was at the actual event, which was the graduation for SCI-Arc. And no one complained about sun in their eyes. We were very happy. So this is sort of the last part that we're going to talk about quickly, which is transitions. Really about, what's next for us and what else have we been doing other than the installations. About, I would say, 4 to 5 years ago, we actually, simultaneous to all of our installation projects, have actually been doing really large projects in Asia. And the first, I would say, three years, while we did many proposals, we actually didn't get any real projects. But in some ways, we feel like it was a blessing in disguise because, at that point, we've only done these really small projects, and to jump scale to a 16-story tower, we actually really didn't know how we would jump scales. And so, of course, our initial projects, which I think, while it has the ideas that we're interested in, I think in terms of just like literally taking our lines and then blowing it up bigger, it is more or less what we were trying to do. But I think also working in Asia, we were under the kind of strict requirement that we can only work with the first 5 feet of space and not touch the floor plan in any sort of way. So that was also a big challenge. How do you create any layer, space, create any variation, and do something great within 5 feet of space?
So in retrospect, we look back at these projects, and quite honestly, we're kind of critical of that approach we were taking at the time. On one hand, we only had so much space to work with. On the other hand, there was in many parts of it, we gleaned a few interesting things from it, but in many cases we were finding that the scale of the pieces was wrong. It no longer operated structurally. It was applique of that idea. So we've been forced to rethink those ideas at different scales and fighting for greater depth.
And so I think this was a project we started last year, and we realized that we can't just pull lines and large lines onto the face of a building, but it actually requires the play of both surfaces and lines. And so, and while all of these projects are actually housing, which means that you have very repetitive balconies that we had to deal with, and they couldn't be relocated. How do you deal with that, and how do you still create variation that we were interested? So, happy to say that this is going to be our first built project in Asia. It's also 16 stories, and this was stemming from taking lines from the activities from the streets and pulling them up. However, we actually call this project our low-res high-rise. So first, the top drawings show kind of the variations of movement on the facade, dealing with both the location of windows and balconies. And then the drawings below that are almost like pixelizing these movements into larger panels of various materials, as well as reinforcing them with lines. So this is from the ground view up. You can see sort of play of these panels. They're shifting incrementally to create variation and also depth as well.
And this wasn't, moving to this kind of work wasn't at the insistence of the client. It was us really realizing that there was an appropriateness to the scale of this that worked better with the city, that worked better with the scale of residential development, but still was in keeping with the kind of dynamic sense of line movement that the previous projects had.
And the final project we wanted to show really quickly is another project. We call it the high-res, low-rise. And this is also a skin project. We were working with the client IAC. You guys might know the building in New York. And we were given a existing 8-story 80s type building that we are creating a new identity for. And this is, we were interested in using a screen material, so mostly surface, actually not a lot of lines. And through the kind of rippling of the material, it actually flows down to the moment on the lower right, where is the actual restaurant. And so zooming in, but there's actually a layer of structure behind it as well. So, and one last video before we finish.
Fitting that you are here today in the space designed by two of the faculty members, Dwayne Oyler and his partner Jenny Wu, for this graduation ceremony. And the unusual nature, believe it or not, in architectural institutions that support their own faculty and that are committed to the reality of its ideas, which is this thing we're occupying today.
Okay, thank you.
Thank you very much.